Going to get right into it with a new part of a circle, new vocabulary term, and that is a central angle. What is a central angle as far as the circle is concerned? You guys can read it. It's an angle in the circle where the vertex, where the two sides meet of the angle, is the center. It's got to be the center. All right, so up here, an example. Everyone see angle AOB in that circle? That's called a central angle. All right, that's a central angle. Why? Where's the vertex? It's on the center, circle O, center O. Okay, so angle AOB. Central angle. Vertex has to be the center. If the vertex is somewhere else, not a central angle. We'll call it something else later on in the unit. An arc, part of a circle. Part of a circle. Now, symbol for arc. Here we go, kids. Very easy. Whoop! There's my symbol. It's a little arc. Underneath it will be the letters I want the arc to be named. Let me start out with arc AB. Arc AB. Can I find on the circle I gave you where arc AB would be? Sure, here you go. Boom, right there. There's arc AB, and that's how I write it in my notation. Wait a second, Mr. Carlino. Couldn't you be going counterclockwise and start talking about this arc AB instead? Sure, but I'm not going to name it AB then. I'm not going to name it AB. You know what I'll name it instead? Ready? I wouldn't name that arc AB. I would name it arc ACB. Oh, you can use more than two. You're darn right. You can use as many letters as you want. All right, 2 is at the minimum. You can use more than 2 to name an arc. But I would name that arc ACB, so you know exactly what I'm talking about. Follow the order of the letters. A to C to B. Follow the order of the letters. Quincy. Chords? No. Chords are inside the circle. Arcs are contained on the circle. Oh. Chords are a segment too. Arcs are not a segment. Okay? Questions, comments? All right, your first theorem, fact, circle fact, relating central angles and arcs. Central angle is equal to the measure of its intercepted arc. Woohoo! Here's your first circle theorem. And it looks like a mouthful and difficult, but it's not. You'll see what I mean here in a second. Woo. Here's what I mean. If I give you that angle AOB is 60 degrees, right? That angle, that central angle is 60. That means the arc that's drawn to it is also measured 60 degrees. So that would, the measure of arc AB is also 60 degrees as a conclusion. Yep, good question. How do I measure it? Well, here's how, Sophia. How many degrees in a circle? So that part right there from A to B is 60 degrees out of the total 360. That's how that measure becomes. Yes, great question. Okay, so what do you got?
What if, so do you know how we did like AB versus ACB?
Yep.
What if there wasn't a C there? Like, what if there wasn't another?
I gotta put something there for you, Maeve.
Okay.
Because then it becomes a guessing game, which one I'm talking about, right? I gotta put a point C there. Yep, good question. Everyone all right? So I can measure an arc in degrees. Measure an arc in degrees out of 360. All right, there's 3 types of arcs I want you to be aware of. One's a semicircle. I think maybe you might have heard of that one. Real quick, how many degrees in a semicircle then if it's half a circle? 180, perfect, 180. So a semicircle, half a circle, 180 degrees. Maybe you haven't heard of these next two. A major arc. Ooh, sounds big time, huh? Major arc. That's anything greater than a semicircle. So anything measuring greater than 180. And then a minor arc is anything smaller than a semicircle. So I'm going to test you guys right off the bat today. My first circle I have here. I need somebody to name a semicircle here. Name the arc that would represent a semicircle. And then we'll do an arc that represents a major arc. And then, yes, we'll do a minor arc to finish this off. All right, first up, name a semicircle up here. Name a semicircle. Nice. Am I looking? 2-6? Good. Up first. Boom! 10. Atticus, name a semicircle. TS, fine. He could have gave me TRS as well. That still would have worked. Okay, T to S. I go right from T to S, no points in between. Done. Semicircle. Give me a major arc now, something bigger than a semicircle. Who's got the major arc up here with the correct letters? 1-8. Owen, here you go. Owen, give me a major arc.
Would it be SRTS?
No, well, that's going all the way. I don't want a full circle here. You're going all the way around on me. SRTS. That's the full circle. I need something a little smaller than that, but something bigger than the half circle.
STR.
STR, fine. Works for me. STR. Arc STR would be a major arc. Not the only response, by the way. Don't think these are the only responses you could say. And then what about a minor arc for me here? Minor arc. Choom, 20. Let's go. Radhika, minor arc. RS is RS, yep. Could have said RT, TR. All good there. All right, I'm not going to ask for these again. I'm only going to, in the second one, all I want is a minor arc. Somebody give me a minor arc in this second diagram. And then the third diagram, give me a major arc. Same diagrams, I know, but. All right, give me a minor arc now in this second diagram. Minor arc. 1-7. Maeve, give me a minor arc there.
RS.
RS, yep. Something smaller than a semicircle. And in the third diagram, somebody give me a major arc. 6, here we go. Caroline, get a major arc there for me? RTS, good. All right, we feeling comfortable? Naming an arc, minor, major. All right, now I want to go back to that theorem I just gave you, which is a central angle is equal to its arc measure. That's what I want to go back to now and use that theorem in these questions. There's actually one more I have to go through. Yep. Adjacent arcs. Well, you guys know, right? Adjacent, always next to, next to, next to. That's the word association, right? Adjacent, next to. But yeah, they're next to each other. They got to share a point, though. They have to share a point when they're next to each other. So if you look at my diagram up there, I'm just going to ask somebody give me 2 adjacent arcs. They have 1 point in common. Arc and arc. Name 2 arcs that are going to be adjacent up there. They share a common point. A couple different answers you could give me. A couple different. 1, 3. Here you go, Sophia. What do you think?
Arc AB and arc CAB.
Okay, arc AB and arc CAB. Okay, here's the problem. You're giving me this CAB has 2 points in common, A and B. It should only have 1 point in common, CA. There you go. AB and CA work. Okay, they should only have 1 point in common. Good, good. So with 2 arcs next to each other, 1 point in common. All right, let's start doing some number crunching now. What do you say? Find the measure. Measure meaning in degrees. Give me the degree measure of these arcs I'm asking for. Arc AE. Here's where I'm going to use that theorem right now. Arc AE is the same measure as angle ACE. It's central angle. That's the theorem we just wrote down on the first page. Arc AE is equal to its central angle ACE. What do you got for me? What's going to be the measure of that arc? 20 going again. Radhika, what's the measure of that arc?
90.
90 degrees because the central angle is 90. Perfect. And I'm going to let you guys go and go ahead and finish that for me. And then I'll go rapid fire calling on people. The arc is equal to the central angle. Follow the order of the letters, remember. Follow the order of the letters. All right, what do you say here? What do you say? ED. Twos. Hannah, what do you got, Hannah? ED? 50 degrees. Good work. 50. And I always like to keep filling it in as I end up doing it. DBA. Follow the letters again. Follow those letters. DBA. Radhika on fire today. DBA?
220.
220. Yes, indeed. AED. Next one. AED. What do we got? 17. Maeve?
140.
$140. Yep. I don't know if anybody noticed a relationship between number 5 and another arc I've already asked for. 24. Here we go. Emily. ABD.
220.
Same arc in number 3, right, guys? I just called it something different. Same arc. And then finally, BD, which I probably should have asked first because that was given to you. Ooh, ones. Anthony, what do you got over there?
130.
130. Yep. Okay, any issues there? Arc measure equals central angle. Now, what happens if I don't give you the angle? What if happens if it's your old school, remember in elementary school, you made your little pie charts? So if I'm asking for arc AB, so arc AB is the same as angle A, I think that's an S, ASB, but I don't know that angle. But I do know that part up there is 20% of the whole circle. What do we say again? Degrees in a circle? How many degrees? 360, right? So that part represents 20% of 360 degrees. Can you find the angle measure then? What are you doing with 360 and 20? Well, you're not doing anything for 20. What are you converting it into? 0.2, the decimal? There you go. 360 times 20% of that. That's what that portion is. And that's what, 72 degrees? So if the angle's 72, the arc's 72. Everyone all right with that at home? No big deal? And then one more CD for volleyball. Same thing, right? 360, but now it's not 20%, 18%. And that comes out to be a little bit of a decimal, right? 64.8 degrees. So I just wanted to throw that in there because I think I threw that on homework tonight, using percentages instead of degrees. Questions, comments? All right, before I get into this, now we go on the second half of class. You can measure an arc in degrees. We just saw that. It's equal to its central angle. Now what I want to show you is, I want to know actually how long it is. Like if I cut AB out, stretch it out, put a ruler underneath, how long is it? Now that won't be in degrees. That'll be in inches, feet, millimeters. So please, please, I need you guys to understand the difference if I ask for the measure of an arc versus now what I'm going to show you is length of an arc. Measure is in degrees, length is how long it is. Okay, please don't confuse the two. How do I find how long an arc is? Second formula of the unit. First one, circumference equals pi d. Second one, length of an arc. Here it is. I'm hoping this makes sense, this formula, how to find the length of an arc. We're going to first do the measure of the arc, which we've done all class, in degrees, over 360. So what fraction of the circle times, and watch what we're going to multiply it by. It should look pretty familiar. Where did we see that before? Pi d. That's the what of the circle? Circumference. So think about what we're doing. What fraction of the circumference am I talking about? That's what I'm looking for as far as arc length. What fraction of the circle am I talking about? All right. Okay. 3 examples. Leave your answer in terms of pi. So I'm asking you to leave what in your answer? Pi. Don't touch the pi button on the calculator. Here we go. Arc AB. Arc AB, and yes, I should have put another point on here. I'm talking about this arc AB, everybody, right here. I'll just let you know that I should have put like a point C here. All right, there's arc AB. So the first thing I need is measure of the arc. This is what we've been doing all day, the first half of class. What's the measure of arc AB? 21. Zach, what's the measure of arc AB? 90 degrees, because it matches its central angle, which is 90. So 90, I need to put the degree symbol there. 90 out of 360 times its circumference. I already gave you 24, so diameter 24 pi. Leave pi in your answer. So the only thing I should be multiplying is 90 over 360 times 24. Shouldn't be touching that pi button because I want it in my answer. So that's why we have our calculators. We're just taking a fourth of the circumference. That's all we're doing. I want to make sure you guys understand that. We're taking a fourth of the entire circumference is AB. And when you guys do that, you end up with 6 pi. Units, 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 please. Inches. Make sure we got the units there, inches. Questions from you guys? Okay, CDE now, CDE. Be careful of the order, please. C to D to E. What's the measure? Measure of arc CDE, so I can get started on the right foot. Measure of the arc. Going deep, 2.6. Emma, what do you got? Measure of that arc.
320 degrees.
Good. She didn't use 40 because that's CE. She said up 360 minus 40 is the rest of it. Nice, Emma. 320 over 360 times pi. I told you the radius was 9, diameter 18 then. Double it. And then same thing, leave pi in your answer. Multiply 320 over 360 times 18. This is finding the length, how long an arc is, not the measure, that's in degrees, how long an arc is. And then I'm hoping you guys are getting 16 pi out of that. And then you got one more, FGH. Follow the letters. Follow the letters. F to G to H. What is the length of that arc, given all that information? What was the measure of the arc first? Measure of that arc? Will! Good morning, Will. What's the measure of that arc?
135 degrees.
Good job, 90 and 45. Kid can add. And then radius is 3, diameter would be 6. You can leave your answer as a fraction or a decimal. So you could have 9/4 pi, or if you wanted to leave it as 2.25 pi, either one is acceptable for me. I don't mind a couple decimals, but if it stretches all throughout your calculator, leave that as a fraction. All good? Any questions before we end this class on an honors level type question? Because this is all basic up there. This is all basic. Anything going? You ready, Audrey?
I am ready.
All right. I hope I'm always ready. Let's go. It's on like Donkey Kong. All right. Find the circumference. If I know arc JK, seriously, never mind, has a length of 6.09. 6.09. Will, you got that one, I could tell. Round to the nearest 10. Well, first, circumference. What formula am I going to use? Pi d. All right, so they want me to find that. I know the arc length. Let me do it in red here, or pink. This arc length right here, 6.09. And they throw in that 50 there as the central angle. All right. Don't I know a formula where the 6.09 came from? Right? 6.09 arc length equals, here you go, help me fill it in. Measure is what? 50, the central angle, over 360. And what's the rest of the formula? Times pi. Whoa, 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 whoa. Whoa, everyone, time out. Pi d, that's another name for what? So basically, you're telling me you solve for pi d, you got the circumference. You got your answer. Yeah. So you algebra studs out there, I need your help. How do I get rid of 50 over 360? Because once I have pi d by itself, that's the circumference. That's my answer. But how do I get rid of that fraction, 50 over 360? That's fine. Oh, multiply by the reciprocal, huh? I like it. That's one way. Now, Sophia, you have a way?
I just divided 6.09 by 50 over 360.
Okay. Sophia's like, you know what? I got this calculator thing that's got a fraction template on it. So I can do 6.09 divided by another fraction template, 50 over 360. Did anybody just do 50 over 360? Find that decimal, and then do 6.09 divided by copy paste. Remember old copy paste? Yep, you guys just discovered that this year. Yep. I don't care what you do. Do what you're comfortable with. I'll go by the first response, which was multiply by the reciprocal. Yep, good job. So on the right side here, I'm left with pi d. On the left side, rounded to the nearest tenth. What are you guys getting? 43.8? Look good? Inches?
Is that what we're supposed to round for the other side? Oh, yeah, because the other side is up.
Now look. I know some of you might want to keep going and divide by pi, and then take that diameter and plug it back in. But you guys, do you see that this is, I can stop here. Because what is pi d? Circumference. And think about what you would be doing if you divided by pi took that answer, plugged it back in, you're going to multiply it by pi again and just be back where you started. All right? You will have a couple of these tonight, so that's why I wanted to make sure I got a problem like this in. All right, but look at that. Look at that prediction, 10:57. Right on time, 10 and a half minutes ahead. You guys at home, do what you want to do. All right, if you want to start the homework, go right ahead. But do what you got to do. You guys here, if you want to start it, that's fine. Get it done. Don't copy the darn answers off a classroom. Ask me the questions tomorrow. Have a good day, guys.